Good morning, free thinkers. I got a question for you. Is it a wave or is it a particle? Okay, so I'm going to describe some systems and I'm going to explain to you whether I think they're waves or they're particles. Okay, so let's start easy. My magic potion from tigerfitness.com. Okay, I shake my bottle. Inside the bottle, there's liquid. Is it a wave or is it a particle? Well, if you're inside the cup, there's obviously a wave in there. Okay, so call it a wave. All right, now let's zoom back here where I am, looking at it from afar. Now, I shake it and I make it a wave. Now, I make my wave move around in a circle like this. Now, is it a wave or is it a particle? Well, it's a wave because there's a wave inside the cup. But we can track this wave because it's inside of a closed system and the closed system is moving. Okay, so we could also call it a particle. So that's a pretty easy one. All right. Whether it's a wave or a particle depends on scale. If I'm back here and the cup seems small and far away and moving, then, well, it's a particle. But if I get close up and I get down inside the cup, well, then it's certainly a wave. Okay, so let's describe a weirder system. Say I have football, okay, and I throw the football, okay? The laces are spiraling around the outside of the football, all right? You could consider that a wave, okay? This wave is in circles, but it's still a wave, okay? But this wave is also moving through the air, all right? And that means we can track it, which makes it a particle because we can math it as if it were a particle, all right? So is it a particle or is it a wave? Depends on where you're at. Okay, now, how about inside your body? Your blood is pumping from your heart, and that sets up a wave that pushes out to your extremities and then back into your heart again. Okay, and this is a wave in and out, right? But also, that wave moves around and does stuff. So, are you a wave or are you a particle? The answer is you're a system. You're a system that's open to being both. You can track it as one, and you can also use it to do things as another. So let's take this up a level and do some bigger waves. Okay, now let's imagine the Earth. Okay, this is one of my magnet arrays, and you can see how I put a bunch of magnets all North Pole facing out. Okay, and then I've stacked some smaller sphere magnets and they stand up off of the ball. Okay, now you could think of each one of these balls as a particle. You could think of the whole thing as a particle. If it were spinning like this, you could think of it as a wave. Okay, now if you are one of these tiny magnets on the surface, what you experience as magnetism as this little ball is basically gravity. Okay, so what then would a gravity wave be? Well, I think a gravity wave would be something like this. Watch close. See how when I bring my magnet array close, these magnets start to wiggle and do things? Okay. These are the kind of things gravity waves are. Another thing they could be is, what if the whole Earth could move in a wave? What if it got hit in a wave and the whole entire thing moved? Well, then the stuff on top doesn't get affected, but the entire system is affected. And where you would see that is in the energy. Specifically, you can pick it up in plasma or I think in light. So like LIGO lays down two arms like this, and then they're really long. That way, if the whole Earth moves, you pick up a disturbance inside of that light. Okay. And there's no difference between all of these, whether it's the wave inside the cup or the wave inside your body or the wave of two magnets slapping together way out here like that. And that will cause a wave that moves the whole Earth. Okay. The thing that determines everything about this is the scale. Whether you're a wave or a particle with my cup depends on how far away from it you are. And so basically, it's scale that's most important here. And you can eliminate this argument of particle versus wave if you switch the conversation to open system versus closed system. Okay, so that's all. Have a think about that. Waves versus particles. Be a free thinker.